Hello viewers, we have a question on the board for us to answer, and then the question goes as follows. The electron configuration of element Y is 1s2, 2s2, 2p6, 3s2, 3p4. Y therefore A has mass number of 16, B has 3 unpaired electrons, C belongs to period 4, D belongs to group 6. To answer this question, we're going to pick each of the options one after the other, analyze them, and see the one that best answers the question. But before we proceed, what is electron configuration, or what is electronic configuration? Electronic configuration simply describes how electrons are arranged in the orbitals of elements. So electronic configuration shows the distribution of electrons in the orbitals of an atom of an element. Okay, so let's proceed with answering the question. The first option says has mass number of 16. First of all, let's check the atomic number of this element, Y. Remember I said that electronic configuration shows how electrons are distributed in the orbitals of the atom of an element. Now, these superscripts here, these numbers written as superscript here, is what is actually showing the distribution of these electrons, while these are the orbitals. S, sp, sp are the orbitals. Then these numbers here, 1, 2, 2, 3, 3, are the principal quantum numbers, which shows the energy levels of each of these orbitals. Okay, so with this being said, we distribute these electrons using the atomic number. Remember that atomic number of an element is the number of protons present in that element. But in a neutral atom of an element, the number of protons is equal to the number of electrons. So we use this number of electrons to write this electronic configuration of an atom. So to check the atomic number of this element, this is what we do. We calculate the total number of this element, and to do that we add them. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 4 is 16. This is the atomic number, okay, and not mass number. Okay, mass number is defined as number of protons and neutrons present in the nucleus of an element, and this 16 we got from here is the atomic number and not mass number. So option 1 is wrong. Let's move to the next one. Has 3 unpaired electrons. To check the number of unpaired electrons present here, we have to use the last orbital here, which is the p orbital. And remember that the p orbital has 3 degenerate orbitals. Degenerate means equal energy. Now this is the orbital of p. Okay, these are the 3 degenerate orbitals. According to Hall's rule, electrons are filled singly before pairing occurs. So we now pair this. This gives us the total number of 4 electrons in this p orbital. So the 4 here is these electrons. These arrows represent the electrons. Okay, now has 3 unpaired electrons. This is also wrong, because from what we have here, we have 2 unpaired electrons. Okay, let's move to the next one. Belongs to period 4. Now, using this electronic configuration, we can easily tell the period to which this element Y belongs to. And how do we do that? Look at the coefficient. That's the principal quantum number of the last s orbital in that electronic configuration. Okay, and then the principal quantum number in the last s orbital in this element is 3. So this number, the principal quantum number of the last orbital, gives us the period to which the element belongs to. And going by that, element Y belongs to period 3 and not period 4. So option C is also wrong. Then coming to option D, belongs to group 6 of the periodic table. How do we check this? Now, looking at this last s orbital, had it been this electronic configuration ended with the s orbital, the group of elements Y would have been 2. But because we have a p orbital, now this is what we do. The s orbital and the p orbital have the same principal quantum number. Okay, now add the numbers. That's this number of electrons here, the superscripts. Add the 2 of them together. What you get gives you the group of that element. So whenever any element ends with an orbital other than the s orbital, what you do is add the principal quantum number of the s orbital and that orbital having the same principal quantum number. That will give you the what? The group of that element. So these two are having the same principal quantum number, p and s. So adding these 2 and 4, add their electrons, not the quantum numbers, not the principal quantum numbers, okay? Don't add the coefficients. Rather, add these electrons up here. So 2 plus 4 will give us what? 2 plus 4 will give us 6 is equal to 6. So 6 is the what? The group of this element. Therefore, option D is the right answer. Y belongs to group 6 of the periodic table. I believe you were able to learn something in this video. See you in the next episode. Chem Sparks cares. Thank you.